Today we will take a look into event-driven architecture style. The event-driven architecture style is one of the asynchronous architecture styles that is used to produce highly scalable and high-performance application. We can also say that this architecture style has high level of adaptability and can be used for as small applications as well as for quite big, large, complex applications. The event-driven architecture is made up of decoupled event processing components that asynchronously receive and process events. Before we will start look into the topology of event-driven architecture, let's take a look into the request-based model. In request-based model, requests made to the system to perform some sort of action are sent to a request orchestrator. This one, from green to request orchestrator. The request orchestrator is typically a user interface, but it can also be implemented through an API layer or enterprise service bus. The role of the request orchestrator is to deterministically and synchronously direct, please pay attention, deterministically and synchronously direct the request to a various request processors. So we have different request processors, and the role of orchestrator is to redirect, to forward the request that is coming to specific request processor. The request processors handle the request either retrieving or updating information into database. As you can see, here we have just only one database. And we take a look into this request-based model because most of the application follow such model, which is called request-based model. And now let's take a look into the topology of event-driven architecture style. There are two primary topologies within event-driven architecture. The first is called the Mediator topology. Second is broker topology. It's two different topologies, Mediator and broker. The Mediator topology is commonly used when you require control over the workflow of an event process, whereas the broker topology is used when you require a high degree of responsiveness and dynamic control over the processing of an event. So depends on which kind of requirements you have, you can choose the Mediator or broker topology. Currently, at this moment, I believe that it's not clear what is under the hood of these terms as broker topology and Mediator topology and how they looks like. We will take a look. But before we start looking at the examples, how they can look like, let's also point that the choice between the broker and Mediator topology essentially comes down to a trade-off between what? Between workflow control and error handling capability versus high performance and scalability. So this is a trade-off between what we should choose, the Mediator or the broker. One of them can propose workflow control and it will be more easily to handle errors. But from other side, another one has such things as disadvantages, but it can propose high performance and scalability. Although performance and scalability are still good within the Mediator topology, they are not as high as with the broker topology. Now let's take a look how the broker topology looks like. This is one of the examples. The broker topology differs from the mediator topology in that there is no, we can highlight this word, there is no central event mediator. So in the broker topology, there is no mediator who will mediate all the workflow. Rather, the message flow is distributed across the event processors component in a chain-like broadcasting fashion through a lightweight message brokers. So as you can see here, we have the list of event processors, and the flow goes from one of the event processor to another one event processor, and so on. And also here we can have all communication are implemented through the queues. It can be, for example, Kafka, one of the technical proposal solution that can be used for this one with different topics. And so all communication are implemented through asynchronous way. So it is asynchronous call. That's why it is one of them also like distributed architecture style, and that provide asynchronous communication. But what will happen if, for example, the error will be generated somewhere? Will it be easy to handle such situation or not? Somewhere it means inside of one of the event processor, then the flow will stop. But at least we will know where it happens and we'll try to handle it. What else? So generally, you can see here in this image, there is initiating event. This is the initial event that starts the entire event flow. It can be simple event like some order, or it depends mostly on the domain. But we have some initial event, and the initiating event is sent to an event channel in the event broker for processing. But also we have to pay attention that there is no mediator component in the broker topology managing and controlling the event. A single event processor accepts and initiate event from this event broker. So, and it begins the processing of that event. What kind of, yeah, I believe that's currently enough, but now let's take a look for just want to mention one more thing. I guess it will make sense before we will switch into the mediator topology. Here you see one of the schema, one of the proposed solution, but it doesn't mean that we have to follow exactly this exactly this image. You can make it a little bit even more maybe stable. If, for example, for one of the event processor, let's say we have one of them is notification event processor, you will add one more queue, one more topic, and you will put here additional information from the request that is coming. And this topic will not be used by other event processor. You can ask, so why we should do this? What the sense of put additional information to one of the topics? How it can help? It is like a good practice within a broker topology for each event processor to advertise what it did to the rest of the system. So For example, let's say one of the processor will send email, and this email is generated and sent to a customer, notifying them of particular action taken. What if other processor will not listen this event? What will happen? Then this information, or for example, I know some of the topics was not available, so some of the information will be lost. In case if you will have additional topic where you will that will be used as a just to register all of the action that was happening by this event processor, you will be able to use it and do not lose some of the information. Okay, what else? So just pay attention that this model can be extensible. So you can put here additional queues. You can put additional event processor. From one queue, you can read, for example, as it is here, by 2 event processors or more. So you will be the author how to build all of these actions, but the general behavior should be identical. Another one approach is to use Mediator instead of broker topology. What it is? So the central to this topology is an event mediator, which manage and control the workflow for initiating events that require the coordination of multiple event processors. So here we have the central place that will coordinate all of the action that is happening between event processors. What is the crons and prons from this approach? And by the way, pay attention that all of this communication are made also on based on asynchronous communication, so we will use some queues. From one point of view, that maybe error handling can be better or no. That if something is happening in one of the event processor, then event mediator will be he will be able to manage it. But what will happen if event mediator will not be available? What will happen if something will happen with event mediator? Then everything will fail. And it will be hard to understand in which of the step it failed, just to recover and continue this flow. So the responsibility of this event mediator in such topology is much more higher than in broker. Yes, let's move forward. And now let's take a look for one of the examples. So we will talk about asynchronous capabilities. And here, the event-driven architecture style offers a unique characteristics over other architecture styles, in that it relies more on asynchronous communication for both fire and forget processing. So it means we send something and forget about it. No response required, as well as request reply processing response required from the event consumer. So this asynchronous communication can be powerful techniques for increasing and the overall responsiveness of the system. Here you can see the example on these images, where a user is posting a comment on a website for a particular product review. And let's assume the comment service in this example takes 3000 milliseconds to post the comment, because it goes through several parsing engines. So what kind of parsing engines? Before the user will post the comment on the system, these parsing engines will try to understand either any like bad words on his comment, is it grammar correctly or not, maybe some additional checks before this comment will be posted on the service. So that's why altogether it will take 3,000 seconds. And the top pass utilize synchronous RESTful call to post the comment, and it means like 50 milliseconds in latency for the service to receive the post and 3,000 milliseconds to post the comment, and then 30 milliseconds in the network latency to respond back to the user that the comment was posted. So generally, if we will add for this 3,000 plus 50 and 50, we will have this value 3,050 milliseconds when the user will see the comment when he posted. Is it acceptable way, like from user perspective? So let's imagine we design the system and now we are the users. We go to some site portal, we just post the comment and we wait 3,000 milliseconds when we will see our comments on this site. Will you be happy if you are the user of such system that the request takes too much time? But what we did, we implement all of this functionality based on the REST communication. So we, in this approach, for example, we decided that we will use API endpoints, and so we will get the request, process all of this request, and then return the response. Was it the best choice to do? Maybe we can make it something more user-friendly. What it means, for example, in another case, now let's look at the bottom image with pass and notice that with use of asynchronous messaging that is used here instead of REST communication, the response time from the end user's perspective for posting the comment on a website is only 25 milliseconds, comparing with such huge value. So I believe that from the user perspective, he will be much more happy when he will get high responsive for his request. He just posts this comment and he will be able to see that the comment will be posted. How can we achieve this? So what we can see here, the response time from the end user, it will take just only 25 milliseconds, comparing with 3,100 milliseconds. So generally it will take 3,025 milliseconds to post the comment. But from the end user perspective, it's already been done. So it means we will fire this message and user will forget about it. But later on, his message will be proceed for all components to check the grammar, to check for the bad words, and so on and so on and so on. So this is example that shows difference between responsiveness and performance. When the user does not need any information back, why make the user wait? Responsiveness is all about notifying the user that the action has been accepted and will be proceed momentarily, whereas performance is about making end-to-end process faster. So just pay attention for this, that sometimes maybe you need to resolve another issue. Maybe you need to resolve not the performance issue. Maybe you need to concentrate more on responsiveness for the end user. It depends from the quality attribute, from what has high priority. And also just pay attention, maybe you will resolve not needed task that or wrong task. If you determine the wrong quality attributes and architecture characteristic, and you will design great system, quite good system, but the stakeholders will require something else, another one that not you will concentrate maybe on the wrong things. Just pay attention for this. What else? Error handling. So yeah, from this perspective, what will happen if during this processing the error will happen? Because for this case, this is much more easily. If the error will happen, then we will notify the user. But when we have the request response model here, how can we handle these issues? So this question is raised. And the main issue with the asynchronous communication is error handling. In general, you will see that yes, there is some tactics approaches that somehow can try to resolve this issue, but still, this is a trade-off between what has high priority. So while responsiveness is significantly improved, it is difficult to address error conditions, adding to the complexity of the event-driven system. The next section addresses this issue with a pattern of reactive architecture called a workflow event pattern. So the workflow event pattern of reactive architecture is one way of addressing the issues associated with error handling in an asynchronous workflow. And here you can see this approach of workflow event pattern. So this pattern is a reactive architecture pattern that address both resiliency and responsiveness. In other words, the system can be resilient in terms of error handling without an impact to responsiveness. You can see here the next approach. So once the workflow processor receives the error, it tries to figure out what is wrong with this message. It could be a static deterministic error, or it could be leverage some machine learning algorithm to analyze the message to see some wrong data or something like this. So yeah, it can be the workflow processor can try to programmatically make some changes to resolve it, like try to repair the data, the request, and then send it back to the original queue. And so if it means like if this data was repairing successfully, when this action was like handled in a correct way, then it will try to push it back to the queue from where the event consumer will try to read one more time. So we will have the loop where all errors that it will be happen, for example, in event consumer, will be put it into additional queue that will be read by workflow processor, trying to handle this such situation and send it back to handle and do not lose something. This is one of the techniques that can be used. The event consumer sees these messages as a new one when they receive from the workflow processor and tries to process it again, hopefully this time with some success. Of course, there are many times when the workflow processor cannot determine what is wrong with them and what was the reason. And in these cases, the workflow processor, this one, send the message of to another queue, which is then receive it, what is usually called like a dashboard or something like this on application that looks so this is like notification that something goes wrong, and workflow processor is not able to fix it. So it can be like support team, admin team that will be notified that there was an error. What else? Yeah, actually, maybe just to illustrate it, it will be quite good. Yeah, it's another one, preventing data losses. Before we will go here, so you can imagine that if we will put, for example, the numbers of flow, how it goes, like we can say that we have, let's say, action 1 here, action 2 here. What else? If there is something bad, then action 3 goes here, then back to event channel, then one more, like 3, 4, 5, and so on and so on and so on, until it can be handled or fixed. Another one key point when we take a look into the event-driven architecture is preventing data loss. So data loss is always the primary concern when dealing with asynchronous communication. Unfortunately, actually, when we choose such approach, there are many places where the data can be lost with this event-driven architecture. By data loss, it means that the message getting dropped or never making it to its final destination. Hopefully, there is some techniques and that can leverage to prevent the data loss, but still we have to pay attention that it can be happen. This is also one of the trade-off. So here is in the first image, you can see the place where the data can be lost. So it can be lost here or here or here. So there are a lot of opportunities to lost the data. Maybe the message will never go to the destination event channel, or maybe processor B will not be able to read from the event channel or to write the data to the database, and so on and so on and so on. Each of the issue can be handled by different techniques, and here you can see the name of these techniques. For example, for such cases, it can be used synchronous send. Here, client and knowledge mode. Here, last participant support. Each of them is different techniques. We will not go deeply into like each of them like right now, but for example, if we will take a look for each point number 3, when the event processor is unable to persist the message to the database to the some data error, so it addressed through leveraging the transactionality ACID, atomically consistency, isolation, durability transaction via the database commit. Once the database commit happens, the data is 100% persistent to the database. And leveraging this last participant supports, it is called this one, last participant supports. So it removes the message from the persistence queue by acknowledging that processing has been completed and that the message has been persisted. And it will guarantee that the message is not lost during the transit from event to the database. So this is like key points how it can be resolved. If we will now choose, let's try to choose between request-based and event-driven. The request-based model and event-based model are both approaches for designing software system. However, choosing the right model is essentially to the overall success of the system. It is recommended to choose the request-based model for well-structured data-driven requests, such as retrieving customer profile data, when certainly the control over the workflow is needed. And it is recommended choosing the event-based model for flexible actions, events that require high levels of responsiveness and scale with complex and dynamic user processing. Here you can see the trade-offs between, for example, better response to dynamic user content. Trade-offs is only supports eventual consistency, and so on. So it depends in which case, what kind of task you have. If you have something well structured, that maybe a request-based model is better choice. If something flexible, then event-based model will works better for this case. Of course, it can be some hybrid of event-driven architecture, but to be short, they are not recommended to use at all. Let's try to summarize what we have with event-driven approach. Here is the rating, and we can see here that the number of quanta within event-driven architecture can vary from one to many quanta, which is usually based on the database interaction within each event processor and request reply processing. Event-driven architecture gains 5-star for performance, scalability, and fault tolerance. So this is like quite big point and marks. So we can see here scalability is quite good, performance is also quite good, fault tolerance also. Overall simplicity and testability rate is low because it's not simple to implement at all. So it will take a lot of effort for the team, and to test something, it will also be quite complex things to do. And finally, event-driven architecture are highly evolutionary, hence it takes 5-star. So it easy to change, it's quite simple, and so on. So you can see here that some of the marks is much more bigger than, for example, we have with the monolithic layered or pipe and filter approaches, and for example for scalability. But from the other side, we can see that if we will compare the simplicity and testability, it will be much more complex to do than with the monolithic one. Next that we will take a look, it will be space-based architecture style. Now let's make the pause.